Hi, 8th graders. Today we're starting a new chapter, and it's fractions, decimals. There's a few new things in here that you did not learn last year, so it's kind of a conglomeration of new and old, but today we're talking about fractions and decimals, so this is lesson 3-1. Okay, so this last year, we talked about this quite a bit last year, changing fractions to decimals and vice versa. So the first thing I want you to do is I want you to make sure, let's see, move that guy over there. I'm going to make sure that you have this in your notebook to convert a decimal to a fraction. The first thing you have to do is you have to think of place value. So we're going to take a decimal, again, we're going to turn it into a fraction. The first thing you got to do is, like I said, think of place value. Now, if I think of place value after the decimal, just try to remind yourself what these place values are called again. A lot of times kids say the oneths. There is no oneths. This is tenths. This is hundredths. This is thousandths. And to be honest, that's about as far as we're going to go for today. So to change something to a fraction, you're going to look at the decimal and you're going to read that to yourself. If you say 9/10, that's how it should be read to change it to a fraction. If you would say 0.9, that is not going to work. So it has to be read with the place value. So 9/10, like I said, read as 9/10. Now, if you read it with the place value, that's automatically going to tell you what number's in the denominator of the fraction. Notice tenths is here and 9 is up on top here. So that place value is automatically going to tell you what number goes on the bottom of your decimal. Okay, so if I look at the next one, it says 0.75, which is read as 75 hundredths. And then notice how the hundredths is on the bottom, 75 is on the top. Another thing I need to remind you is that everything needs to be reduced if it can be reduced. Okay, so if I look at 75 and 100, I know that can be reduced. That can be reduced by a few things. It could start with 5. You could do it by probably 15. I don't know about 15, but 25 for sure it could be done by. And this is how we did it last year. You found what they shared. Divide by 25, divide by 25. This is going to be 3/4. And everything today needs to be reduced as far as it can be when you are changing decimals to fractions. So let's just do a few more just to make sure you get the hang of it here. So I have, we'll say this is 1, we'll say this is 2, we'll say this is 3. Okay, so this first one is read as 3/10. So that should be written on your notebook like this. Can it be reduced? Nope, that's your final answer. So that one checks out. The next one says 0.55, which is read as 55 hundredths. So that's going to be written like this. Then you need to ask yourself, can this be reduced? Yes, it can. I know it can be reduced because one ends in a 5 and one's in a 0, so I know that they can be reduced by 5. So let's see, reduced by 5, I get 11 over 20, and that's going to check out also. That's as far as I can go. Over on the side here, I have 0.368, read as 368 thousandths. So I'm going to start this one down here, actually, because this can be reduced by a lot. If I look here, I know it can be reduced because they're all even. That should be the first thing you look at, is if they're even. If they're even, it can be reduced. So I'm going to reduce by 2. Let's see, this would make this 500. This would make this, I want to say 189. No, 184. Sounds more like it. Okay. It can be reduced again by 2. So let's see, I would get 92 over 250. Okay. It can be reduced again by 2. So let's see, I would have 125, and this divided by 2, I believe would be 46. I think I'm doing that right. I probably should make sure. Let's see, 92 by 2. Yep. And then if I look at 46 and 125, let's see, can that be reduced again? It cannot be reduced by 2 because it's not even. They both aren't even. And if I look at 125, I know the only thing that goes in 125 would be 5 and 25. And I know that doesn't go into 46. So that's actually going to check out. And that would be the end. That would be as far as you can reduce. And I don't think you're going to have anything like this quite like today, but just know that you got to reduce as far as you can. Okay, so the next thing you need to have in your notebook is this, to convert a fraction to a decimal. Now we're going to go the opposite way. We're going to have fractions and we're going to change them to decimals. Before, we could change decimals to fractions. Now we're going to go the other way. Now a lot of people, when they see something like this 3/8, they automatically just do this. Oh, I got a 3/8 in there and I put a decimal. That is not how you change something to a fraction. If you look at this fraction, it's actually a division problem. And we've talked about this multiple times last year. This says 3 divided by 8. So if you're going to figure out what 3 divided by 8 is, 3 is going to go inside the house. The top number is always in the house. That would probably be something you need to write down. Top number in the house. That is like the biggest thing. Then 8 on the outside. Then you can start to do your division. Now let's think about it. 8 doesn't go into 3, so I'm going to add a decimal point and a 0. I'm going to put my decimal point up directly up on top. 8 goes into 30 3 times. I'm going to get this out of here. Minus 24 gives me a 6. I'm going to bring my 0 down. 8 goes into 67 times. I get 56. 4, I'm going to bring a 0 down. 8 goes into 45 times. And that ends in a 0. So 3/8 is 0.375 in a decimal. Now, there's a term for this, and it's called a terminating decimal. Terminating decimal is something that ends, something that completely stops. It doesn't go on. So, like for example, like 1/2 will be a terminating decimal because I know 1/2 is equal to 0.5. Some other ones that you probably should know off the top of your head: 1/4, 0.25, 3/4. 0.75. Pretty much anything that is divided by 8 like this is going to terminate, going to end. So those are really common ones that you will probably come across multiple times. So just kind of start getting to know those off the top of your head because it'll make your life a lot easier in the long run. So terminating decimal is a decimal that ends. Now another vocabulary word we have today is repeating decimal. A repeating decimal repeats over and over and over again. It does a certain pattern. So when you divide, so this is an example right here, 2 over 111 or 22 over 111. If I would start doing that division, answer is gonna start looking something like this: 0.261, 261, 261, 261, and literally it's gonna go on forever. Forever. It does not stop. So there is a way, and we talked about this last year. It's called the bar notation. Bar notation is a line that's placed over only the repeating part of the decimal. So here's an example. If I was going to put 0.261, if I was going to write this 0.261, I would just write it like this because that tells me that 261, 261, 261 repeats over and over and over again. Here's some other examples. Let's see if you come up with your answers this 0.123, 123, and it just keeps going. This is how you would write that in bar notation. Another example, sometimes you'll get a decimal that'll like repeat like this. Okay, notice the 3 is the only thing repeating. So this is how you would write that with just that line over the 3. Another example that I have for you is that you might have something that, geez, maybe it's 8 that repeats over and over and over again. And we're going to talk about this more tomorrow. We talk about repeating decimals a lot in the next lesson. But if you're going to write this in a bar notation, usually we write it as simple as possible. So we would write it 0.8 repeating, not saying that this would be wrong, but just notice that this is the most simple way, and that's what we're always aiming for, the simplest way to write things. Another thing I want to talk about quickly is, let's say you have that decimal that repeats like this. You say, oh, I'm going to write it like this. That's fine. But then let's say one of your friends writes it like this. Okay, you have to know how different these are. Yeah, that's maybe what happens in the decimal, but that is not repeating. So this is how this would look like written out. Okay, but this one would actually look like this. So just know that if you would happen to make an accident and put it over another number, you're going to have a total different answer when it would be written out. So be careful with that bar notation. You're only putting it over what repeats. Come on. There we go. Oops. Oh, we're way too far. Okay, so let's do some. Let's decide if they're going to terminate or repeat and kind of figure that out a little bit. So let's just try 5 over 33. So this is how it would look. Okay. 33 goes into 50 one time. Okay, I'm just going to keep going here. Let's see, I have 4, 10, 17, 0, so 33 times 8, 4, carry the 2, 24, 25, 26. Okay, that's a little too high. 33 times 5 would be 15, 165. I'm just going to keep bringing zeros down. Oh, I can see already what's going to keep happening. Notice how I'm starting to copy and paste my work. Notice how this is going to start copying and pasting. That means if I see a pattern where it's going to start copying and pasting, that means that I'm going to have a repeating decimal. So this one is evidently going to go like this. So I know to write that out, it would look just like this. That's how it would look. Okay. Now, if I do this one over here, 13 divided by 16. Let's see. Oops. 116 times 7, 8, 9, 10, 11. 16 times 8, 28. There we go. 2. I believe that's going to be 32. And I get 8. Pretty sure it's a 5. Yep. It's going to end, and that's a terminate. That's an example of a terminating decimal. Okay, a few other things quickly that I want to show you is if you are given a whole number and a fraction, which is called a mixed number, there's an easy way. Some of us like to do 8 times 1 times 2, so 8 times 1, I'm sorry, plus 2, 8, 9, 10. This is also 10 over 8. You could change it to a decimal by changing into an improper fraction and then dividing. Another way is what I tell the kids is forget about the whole number in front. Figure what this out is in a fraction. I know 2 divided by 8. Let's see, I'm guessing it's going to be 0.25 after I do my division. And then I would bring the whole number in and after that. So 1.125. That's a really simple way where you don't have to make a mixed number. So just by taking, so if I have this, I would find what this is in a fraction or in a decimal, 0.4. And then I would bring my whole number down and put it in front. So that's a really simple way if you have a whole number and a fraction to find the decimal from that. All right, the last thing you're going to have to do today is you're going to have to compare. Now, sometimes you won't have to compare fractions. Now, if you have a fraction, you can also make common denominators. Like if you're comparing two fractions, like over here, I know 4 and 3. 12 is a common denominator. Now, if you don't remember how to do that, 4 times 3 is 12, so I'm going to have to take 1 times 3. 3 times 4 is 12, so 2 times 4 is 8. So this is what our problem would look like. And then you have to say what's greater or less than. Well, if you're a negative number, you got to think, okay, what's closer to 0? I have negative 3 12s. I have negative 8 12s. What's closer to 0? I know this is going to be closer to 0 because negative 3 is greater than negative 8. Over here, if I look at my decimals, I know 1/3. This is another thing you need to put in your mind is 1/3 is 0.333 repeating, and this is 0.3. Now, if you're going to compare these two things, if you want to, you could put a 0 behind here and say, okay, well, let's compare. I know that this is going to be greater because it has 3's all the way behind it. It doesn't mean that just because it's a longer number doesn't mean it's always bigger. It doesn't always work like that. But just comparing the place values, like I know those are the same, then I would have to look at these. That tells me that this one right here is a greater number. The last thing I want to do is I just want to look at some decimals quick. So 0.25, and then if I have 0.246. This is what I mean by just because it's a longer decimal doesn't always mean it's bigger. This is how you can tell. You just start by looking at your 10th spot. Okay, your 10th spot's the same. Now I'm going to look at my next spot. Oh, I have a 5 and I have a 4. Well, I know that 5 is bigger than 4, so that's going to be greater than. So it's really important to look at your place values. Just because a number is longer does not mean that it's going to be greater than the other number. So, all right, if you have any questions, let me know. I'm going to go over a few more things in class with that probably a little bit. So if you need any help from me, please make sure you let me know tomorrow. All right.